Welcome back to Module 2. I'm your professor, Professor Fiske, and in this class, we are going to talk about iterative statements. And in this specific lecture, we're going to discuss for loops. Now, if you haven't liked or subscribed, please do so. It really helps with my content delivery, understanding what you're looking for, and how to help you. Otherwise, let's get started. So, what are iterative loops? Iterative statements, iterative loops, are loops where we want our block of programming statements to execute more than one time. In the last lecture, we talked about while loops and do while loops, but those aren't used nearly as much as the looping structure or the iterative statement I'm going to explain to you now. The iterative statement that is used far more than do while and while is the vaunted for loop. Now, why is the for loop so important? Why is it used so prolifically? Well, the for loop is used so prolifically because the for loop loops over an array of values, an array of things. And that's very important because in most situations when we have a data set, our data set is in the form of an array or list or a dictionary. And those three different structures, those three different data structures allow us to compartmentalize our code and compartmentalize our data in a way that is clean and contiguous. I'm going to take it a step further. I know this is not a lecture about arrays, but let's talk about arrays briefly. So when I create a variable, first number, the first number variable is an integer, and it sits in a storage location, a storage block in your random access memory. Now, the word random is very important because your random access memory is random, which means the storage is randomly selected by your CPU. So when your CPU computes, it uses your random access memory kind of like you do in a math test when you're writing your math problems out on a piece of paper. And it saves certain equation solutions to use later. Now, the way it stores that is not that it picks a certain file location and stores it there. It doesn't do that. Just like in your math class, you might write on random spots on your paper, circle it so you remember where it is, and you can come back to it. That's almost exactly the same way your CPU computes and stores its algorithmic outcomes. Now, why is that important? When your CPU randomly selects a storage location in your RAM, that storage location might be eons away from the next storage location that it determines the next variable should be, which would dynamically and it would make your program less efficient. Slow. Very slow. Especially if you have a lot of RAM. Back in the day, we had kilobytes of RAM, and that seemed like a lot. If you look at like documentaries on the spaceships Voyager 1 and Voyager 2, those spaceships are still in flight, and we're still using them, and they're still really, really robust. But the amount of RAM they had on those space flights was 40 to 70 kilobytes of RAM. Imagine if those spaceships had more power than they do now. What could they do where they are near the Oort cloud and things like that? Well, I digress, but to let you guys know, arrays are more efficient than variables because when an array is stored in your random access memory, it is also put in a random location. But every subsequent position that your array has is stored next to the first position. Now, an array can have a finite amount or an infinite amount of positions relative to the finite amount of space that your RAM has. Meaning, if I had positions 0, 1, and 2 in an array, those positions are right next to each other in the array. Unlike if I had three variables that I was using that are now in three separate storage locations, making my program very much so not efficient. So there is one example, and I don't want to really get rid of all this because this is really good work that I like to keep for my lectures. So I'm going to go ahead and save this somewhere else. But actually, yeah, I'll save this somewhere else. There. That's going to error out. I don't care. I just want to save it. I could have made this a text file. Rename text. There, now it won't crap on it. Yeah, now it won't crap on it. It doesn't care. All right, cool. Cool. So, now what I'm going to do is I'm going to come into here and I'm going to change this integer to a string because I know my strings are all arrays. They're character arrays. So we'll say char, and then we'll give it a name. We'll say first name. What am I doing? I always mess this up. Is it char array? All right. Okay. What is it Yeah, I did it right the first time. I don't know why it's complaining. Oh, it's because of the number. It's been a long day. All right, first name, and then we'll say, again, John. Wonderful. Now we have an array. I know this is a string, but that doesn't matter. This is an array, all right? It is an array of characters. You agree? Perfect. So now let's make a for loop to loop over this array. I want to loop over the array, and I want to print every letter individually. I want to print every position in this array individually. And there's 4 positions in the array, starting at the letter or the number 0. So J is at the 0th position, O is at the 1st position, H is at the 2nd position, N is at the 3rd position. All right? These are 4 positions, but in computer science, in programming, in software engineering, we always start counting at the number 0. So we're going to do a for loop. Now, what's important about a for loop is a for loops have 3 parameters which we need to enter. Some of these parameters, I know that not all the parameters are mandatory, but I'm going to say they're mandatory because, in my opinion, you should always use all 3 of these parameters. So for the for loop, which is looks like a function, by the way, there are 3 parameters. Our first parameter is our iterator. Now, our iterator is our counter. It is the thing which lets us know how many loops we've already completed. Okay? You can start at 0, you can start at 1. It doesn't matter. You can start wherever you want. But normally we start at 0 with a normal, simple for loop. The second thing we want is we want to know when to stop. We want to have a sentinel value. We want to have a Boolean expression that tells us what is the condition which lets the loop know we're finished. So I could theoretically just count the positions in this array and then use that. So that's what I'm going to do at first. And then we're going to refactor this. And I'm going to show you a more dynamic way to do this. But either way, we're going to say as long as first name is... No, as long as I, our iterator, is less than 5. Less than 5. And the reason why I'm saying less than 5, you can also say less than or equal to 4. That's fine too. We're basically letting it know as long as we are less than the amount of spaces or the amount of positions in the array, we should be fine. And the last thing I want to do is I want to increment this by 1. Now, this is a very important operator I want to show you. This incrementer is shorthand. What this actually means is I equals I plus 1. That's a lot of characters to write. That's a lot of symbols to run. And it's not as efficient as saying, well, you know what? Plus plus. That increments the iterator by 1. If I wanted to increment or decrement, if I wanted to go in the opposite direction, then I would say minus minus. Now, there's one more thing I want to show you about this incrementer and decrementer. You don't always have to put the increment or the decrement after the iterator. It is normal best practice to do this because when the for loop finishes its loop and it hits this last curly brace, this incrementer or decrementer, whichever one you're using, is going to fire. When you put this after the I, what you're saying is I want you to fire after the iteration is finished. If I put this before the I, which you totally can do, what you're saying is I want you to increment at this curly brace, which is before our programming block. There are situations where we want that. This isn't one of them. So I'm going to say plus plus and move on. Great. So we have 3 parameters in our for loop. We have our incrementer, or we have our counter, which is our iterator. We have our, and this could be any number, this is, or any name. This is a variable, okay? We're using it as a parameter, but it's initialized. Isn't that eerily similar to this? They both have the same syntax, no? You have the data type, you have the name of the variable, you have the equal sign, right? And 1 equal sign equals, or 1 equal sign means assignment. 2 equal sign means, can't hear you. 2 equal signs mean, you're right, it means equality. So right now we have 1 equal sign. So this means that John is assigned the value, or I'm sorry, first name is assigned the value of John, and in this case, I is assigned the value of 0. Great. Our next parameter, which is separated by a semicolon, is a sentinel value. It's a Boolean expression. We're basically asking a question. Is this true or is this false? That's what this is going to be determined as. Okay? As long as I is less than 5, do something inside this code block, this block of programming statements. And then when you're finished with this iteration, I want you to loop this by 1. I keep using the word iteration. And I want you to know that iteration means one loop of the loop. The loop is going to loop as many times as it needs to finish. Each individual loop, so this is going to loop at least 4 times. Each individual loop is an iteration. Those iterations are what we're saying we want to count so we know when to stop. All right, so what do I want to do? Well, I really just want to print this. So we'll say printf, and then we'll say, you know, what is going on here. So then we'll say, right, I'm S for the format specifier, and then we're going to take this array and we're going to plug in the I in the curly brace or in the straight braces, like so. Now, what is this doing? What is that? Oops. What does this do? What is this? Well, what that does, I'm going to get rid of this console so it's clear. What this does is it is, format specifies a char, but the argument has type char. Format specifiers are kicking my butt. This should work. Hold on. This should work. It shouldn't cry about it. It didn't work. All right, 1 second. Let me get the right format specifier. Format specifier. And C. I need the one for, it's C. All right, the one for characters. That should be good. Great, it'll work now. So what is this doing? Well, in the event that you only want to get one position in an array, you need to index the array. This is called indexing, all right? Because my iterator is a numerical value, I can plug it in here. However, if I wanted to, and I'm just going to comment all this out real quick. If I wanted to get print f, and then I said I want the character, and I said first name, and I indexed it at the second position, what should I get? If I indexed this array at the second position, what letter should I get? The letter H, because that's in the second position. So let's count together. 0, 1, 2. This is the second position, so I got the letter H. So, because my I is already a numerical value and it's iterating starting at the letter 0, guess what? My array starts at the letter 0. It's going to start at the letter 0 and count all the way through, and it's going to give me all of these letters, like so. Notice it did not break them, so let's break them so you can see them broken up, because that's really what I want you to see. I want you to see it iterating over them one by one. There you go. J, O, H, and N. Now, this is all great and good, but this isn't the end. This isn't the end at all, because this is not necessarily going to be the way that you receive data. Normally, your data comes externally, so that's not allowed. We're not doing that. What you're going to do is you're going to printf and say, please enter your name. And then we're going to do scanf, and we're going to get that data from the user. We also need, I wonder if I can do that here. I can't. Well, I wonder if I can. I don't know if I can do this. No, it won't let me. So I need to declare the variable. So char first name. Once again, I don't like declaring a variable with nothing in it, so we're going to give it something. We're going to say empty string. Perfect. This is empty string. That means that's a string that has nothing in it. Now what I'm going to do is I'm going to come here and I'm going to say, sorry, 1 second. There we go. What is wrong with you? Format char. It won't be a char. It will be, it won't be a char. Definition of variable with array type needs an explicit size or an initializer. That throws a wrench in things, right? 1 second. Let's figure this one out. I just want the scanf to give me a string. Oh, bollocks. I have to tell it how big I want it to be, and I don't want to. I was afraid it was going to tell me to do that. All right, so let's be good arbiters. We're going to say this is 255. Wonderful. So now that that's 255, we'll say this is a C. That should solve the problem. No, it shouldn't. We should say S. What's wrong with you now? Format specifies type char, but the argument has a... Yeah, it should be fine. So now if I said John, enter, it worked. Great. So this is a warning. It's not necessarily a error. When it's yellow or orange like that, it's a warning. So it worked just fine. And we got the data from the end user. But what happens when I put a longer name in here, right? Right now we're only counting to number 5. What happens when I put a longer name in here? Johnny. Well, it stopped counting. Luckily for us, it didn't throw an error. Normally the error is out of index exception. But really, it just stopped counting. It didn't count any further. This is a problem. So what I actually want to do is I want to check to see how long this array is, and then I want to count based on the size of the array. Right now, the array is 255 characters, which makes this a little hard to do. In C, in higher level languages, this isn't a problem. I can basically just, say, give me a value, and then determine how big that a string is based on what I've been provided. But it looks like I have to predefine how big the array is, which I don't like. And I'm thinking that there's a way I can get around this. And I think the way I get around this is by creating another char array. I create another char array. 1 second. Why are you upset? Array initialized must be initialized list or a string literal. That is a string literal. One second. There's a way to do this. I'm just trying to figure it out. So one of the problems, like I said, with C is that strings are not simple. They're not simple to use. They're not simple to a lot of the stuff that's inherent to our interesting. So I can just do this then, right? Huh. That's crazy. And then I don't have to do this. And then I can do this. And then I can do this. And then I can do that. Okay. Well. Didn't work. And that's because input is not happy about this. Right? It didn't like this. It didn't like the... That's because char input, this is a... Interesting. I'm trying to create a string literal. My apologies. This is interesting. I just created a conundrum for myself. That's interesting. Let me see. If I say input dot, what do I get? I get nothing, right? Let's do 255 just for science. Nothing. What I want to do, here we go. That's how you do it. So I'm not going to do this because it's not going to work the way I want it to. But what I want to do is I want to initialize or declare, not initialize, I want to declare the string without a size. I don't want a size. And then I want the size to be dynamically determined by the scanf, right? Dynamically determine size of array. Yeah, I wanted to dynamically decide the size of the array. I don't want to predetermine that. And I thought the answer was this, like that. And what this essentially does is it says that it is dynamically allocated memory, or the memory is dynamically allocated. The size of the array is determined by the size of the array is determined by what exactly? Yeah, I see how they jerry-rigged it. I'm reading some documentation from Geeks for Geeks, and there's a way you have to jerry-rig it to do what you want it to do. I can't just... I don't like this at all. Because what I would have to do is I would have to get the size from the user. When I want to dynamically determine the size from the program, if I ran this and I said John, so I said John, and then I said enter, I won't get anything back because these two are not jiving well together due to the fact that I didn't tell it how big I want it to be. But now that I'm telling it how big I want it to be, then I run this and I say John. See how many times it ran? It ran 255 times, and I don't want it to run that many times. I only want it to run the amount of times that this program has the arrays in it. So I'm not going to keep going with this because this is something I want to do in our array micro lecture. But let's go back to the way it was, because the way it was just fine. If I do it this way, and I ran it, it works just fine. Cool. I normally like to show the real world example, best practice, but I can't do that right now because if I show you that, basically I'm going to have to teach you arrays. And I don't want to get into arrays at the moment as I've gone far enough. So, as I say in all my videos, thanks for watching. Like and subscribe if you haven't. And just hit that button. Hit that button.
Oh, no.
And I'll see you in the next lecture. Good luck. Have fun. Ciao.